everybody got to do.
Okay, we're going to go through the Chapter 3 test review. Hopefully you have already checked your answers that I posted, and so you're just coming here to find the ones that you need help, so skip around as you need to. Okay, number 1, for the data in each table, determine whether direct variation exists. If yes, write an equation for the direct variation. So remember that the equation for direct variation is y equals kx, and so what we're going to do is plug in x and y values and see if k is the same. If k is the same, then this is direct variation. So I'm going to start here. 18 equals k times 2, so then k would have to be equal to 9. So I'm going to look at the rest of these points, and k would have to be 9 every time. So 12 equals k times 3. I'm just plugging in x and y values. Okay. And then k would have to be equal to 4 here. So already I have 2 different k values. I don't have to keep going. I know, no, this is not direct variation. And I don't have to write an equation. I only write an equation if it is direct variation. Okay, 2 is the same thing. So again, I'm going to plug x and y into y equals kx. So 5.4 equals k times 3. And so I'm going to divide by 3 there. I get k equals 1.8. And then I'm going to go with my next value. So 12.6 equals k times 7. When I divide 12.6 by 7, I get 1.8 again. So far so good. I got to check the last one. So 21.6 equals k times 12. Divide by 12. And k is 1.8. So yes, this is direct variation. And then for the equation, it's y equals kx. And I know that k every time is 1.8. So it's y equals 1.8x. That's all I have to do. Okay, 3 is still the same type of problem, so I'm plugging in 9 equals k times negative 6. All right. And 9 divided by negative 6 gives me a decimal, but I'm going to change it to a fraction, so I get negative 3 halves. Okay, and then I'm going to do the same thing here, so negative 1.5 equals k times 1. And if I divide negative 1.5 by 1, I get negative 3 halves. And then one more time, negative 12 equals k times 8. And if I divide by 8 there, I get negative 3 halves again. So yes, this is direct variation, and my equation is y equals negative 3 halves x. All right. Remember, when you get decimals, to change them into a fraction, if you have a Casio, you just press that FD button. It'll change it back and forth. If you have a TI, it's math enter enter. All right, one last time, number 4. So again, y equals kx, and we're plugging in. So 5 is equal to k times 1. If I divide by 1, then k must be 5. And I have 0.25 equals k times 20. So I'm going to have 0.25 divided by 20. And that gives me 1 over 80. So that is not the same as 5. So nope, this is not direct variation, and I don't have to worry about writing the equation. Okay, next question asks you to plot 3 additional points on the graph if direct variation exists and goes through this point right here. Well, remember that for direct variation, it has to do 2 things. It has to go through 0, 0, and it has to be a straight line. All right, so if I'm going to make a straight line, well, I know it has to go through 0, 0, so there's my next. And then I have to make some more points so that this is a straight line. To get from this point to 0, 0, I went up 1, right 1, so I'm going to continue that pattern. Up 1, right 1, put a point. Up 1, right 1, put a point. There's my 3 extra points, so if I connected all those, I would have a straight line that goes through 0, 0, so that's direct variation. All right, here's the same thing. So again, I know that the point has to be 0, 0. Okay. Okay, so to get there I went up 2 and left 1, 2, 3. So I'm going to continue that pattern. Up 2, left 1, 2, 3. Up 2, left 1, 2, 3. Straight line goes through 0, 0. That's direct variation. Now we have everyone's favorite word problems. You guys remember the process doesn't change, okay? So just read the whole thing, all right, and think a little bit. I promise you can figure it out. A bicyclist rode 3 miles in 10 minutes in the morning. In the evening, she rode 7.5 miles in 35 minutes. Does direct variation exist? And if so, what is the equation? All right, well, if it's direct variation, it would fit into y equals kx. So let's see if these points will fit in. So she rode 3 miles in 10 minutes. So I'm going to go like this. 10 equals k times 3. And then I would divide both sides by 3. All right, and so 10/3 is already simplified, would have to be k. Then I'm going to do the same thing with the second set of data. All right, so 35 minutes, because I put 10 minutes here, so I got to match everything up, is equal to k times 7.5, and then divide by 7.5 on both sides. 35 divided by 7.5 is going to be 14 over 3, so k is not the same, so no, this is not direct variation. Alright, now we have some statements. We have to say if they're true or false, and if false, explain why. So the graph of a direct variation may pass through -2, 4. So let's think about that. If I had a graph, if I had a line, -2, 4 would be right here. Could we draw a direct variation graph that goes through that point? Well, sure, because we could make it go through 0, 0 and then continue in a straight line. So this is true. I can go through -2, 4. Alright, the graph of a direct variation may pass through 0, 3. So now, if I go like this, 0, 3 is up here, and that's a problem, because my direct variation has to go through 0, 0. And if it's at 0, 3, I can't draw a straight up and down line, because if I draw a straight up and down line, that would be x equals 0, and that doesn't fit in with my y equals kx. So this is false, okay, because direct variation has to go through 0, 0. Alright, or the name for the point 0, 0 is the origin. Alright, so again we have two scenarios. A person burned 275 calories for 22 minutes, and the next day they did 450 calories in 36 minutes. So again, let's see if it fits into y equals kx. So I'm going to do 275 calories is equal to k times 22. And the other situation would be 450 calories is equal to k times 36. So I got to make sure I have calories in the same spot and minutes in the same spot in each equation. All right, over here, I'm going to divide by 22. All right, and 275 divided by 22 is 12.5. Over here, I'm going to divide by 36. 450 divided by 36 is 12.5. So I got 12.5 for k both times. So now it says I'm going to use the letters they tell me instead of y equals kx. They tell me let n represent the number of calories. Well, we put calories where y is. So I'm going to have n equals k is 12.5. And then instead of x, they tell me let t represent time. So n is equal to 12.5 t. That's my equation. You have $1,000 in your savings account and earn $50 in simple interest. The following year you have $1,500 in your savings account and earn $75 in simple interest. So again, we're going to plug into y equals kx and see if it fits. So 1,000 equals k times 50. And if I divide by 50 on both sides, 1,000 divided by 50 is going to be 20. Alright, so for the first one, k is 20, so let's check the second one. So 1,500 equals k times 75. Divide by 75 on both sides. Alright, and then 1,500 divided by 75 is also 20. So my equation is y equals 20x. All right, given the situation in question 10, so using this equation that we came up with, how much simple interest would you earn when you have $3,500 in your savings account? Well, the amount that's in the savings account, we kept putting in y every time. So I'm going to put 3,500 in y, and that's going to be equal to 20x. To solve this for x, I'm just going to divide by 20. So if I had $3,500 in my savings account, I would earn $175 in interest. And then our last question on direct variation says, explain why all functions are not direct variations. Okay, well, let's talk about some definitions there. So if it's a function, all right, it means that it has only one y value for every x. So that could be a number of different things. That's going to be anything that passes a vertical line test. So it could be a line like this, it could be a line like that, it could be a line like this, it could be a lot of different things. As long as it passes a vertical line test, it's a function. But if it's a direct variation, we know it has to have two things. It has to be a straight line, and that straight line has to go through the origin or go through 0, 0. So that's why not all functions are direct variations, because these don't pass the two requirements for direct variation, which is a straight line and then going through 0, 0. Alright, now we go to the next part, and we are finding the slope. So remember, when we find the slope on a graph, you have to count, and you count from left to right. So I'm going to start at this point and count to this one. So I got to go down 1, 2, 3, 4. So down 4 would be negative 4. And then right 1, 2, 3. So right 3 is positive 3. Negative 4/3 is simplified, so that's my slope. Alright, this one again, left to right, so I got to go up this time, 1, 2, 3, so up 3 is positive 3, and then right, 1, 2, 3, 4, and again, 3/4 is simplified. Okay, then we go to number 3, so I'm counting left to right, so I'm going to go down 1, so negative 1 over, and then over 1, 2, 3, 4, negative 1/4 is simplified, so that's my slope. Here it's down 1, 2, 3, so that's negative 3, and then right 1, 2, 3, so that's positive 3. Negative 3 divided by positive 3 is negative 1, so the slope there is negative 1. Alright, find the slope of the line through each pair of points. So I'm looking for the difference, alright, or how far it is between 17 and negative 17. That's a big difference, big gap there. I don't want to try and figure it out myself, so I'm going to go ahead and do the subtraction. So I have negative 17 minus 17, and that gives me negative 34. Right here, then from negative 12 to negative 4, I can figure that out. That's plus 8. All right, if you want to do the subtraction again, you can. It would be negative 4 minus negative 12. And you get positive 8, then negative 34 divided by 8 can be simplified to negative 17 over 4. Alright, again, if you have your calculator, negative 34 divided by 8, press enter, and then Casio FD will change it to simplified fraction. TI, math, enter will change it to a simplified fraction. Alright, and let me grab a different color. And we're going to do the same thing here. So from 8 to negative 2, alright, that's going to be a difference of minus 10. And then from negative 9 to 17, that's too big. I can't figure that out. So 17 minus negative 9 is 26. So I have negative 10 over 26, and that's going to simplify to negative 5 over 13. Okay, grab a different color. From 8 to negative 15, again, too big. I don't want to try and figure that out. I'll probably mess it up. So negative 15 minus 8 is going to give me negative 23. And then from negative 3 to negative 20, I can figure that one out. That's negative 17. Alright, negative 23 divided by negative 17 simplifies to just 23 over 17, because a negative divided by a negative is a positive. Then one last one, so from 4 to 7, I can figure that one out. That's plus 3. All right, and from -1 to 20, that's plus 21. So I have 3 over 21, which is going to simplify to 1 over 7. Okay. All right, the next two that we have to find the slope of, they give you the equation in slope-intercept form. So remember, y equals mx plus b, and whatever number is right here next to the x is called the coefficient because they're being multiplied. So the coefficient of x is the slope. So in this case, my slope is just -4. For this one, it's just -2. It really is that easy. It's not a trick question. All right. Then we're going to sketch the graph of each line. Now, on the quiz, remember we talked about this. A lot of you guys did this. You said this is y equals -3x minus 4, and then you graphed it from there. But this is not the slope. It doesn't say the slope is -3. It says the x-intercept is -3. So this is not right. You can't do that. Okay? The x-intercept is just where the graph crosses the x-axis. So I know at -3 on the x-axis, my graph has to go through there. And then the y-intercept is where it crosses the y-axis. So at -4, my graph has to go through there. So there's my 2 points. That was a terrible line. Sorry that it didn't actually go through there, but you'll draw it much better. All right. Over here, x-intercept is 4. So 4 on the x-axis. I know that's a point. Y-intercept is -3. So that's got to be a point. And then I'm going to draw a straight line. A little bit better that time. That is that. Alright, this time we're graphing and it's actually given to us in slope-intercept form. So this is what we've been practicing over and over. 1/2 x plus 3, so I know the y-intercept is 3. That's my first point. And then I'm going to use the slope to count. So +1 means I'm going up. +2 means I'm going right. So up 1, right 2, put a dot. Up 1, right 2, put a dot. Up 1, right 2, put a dot. I could continue that process forever. Alright, so I'm going to fill those in. That's it. Okay, y equals 5, this is one of those special lines. And I gave you these acronyms to help remember, so VUX and HOI. Okay, y equals is a horizontal line. So y equals 5 means wherever I put a point, it has to be y equals 5. So it's right there, all right, but we're not going to draw the line vertically because y equals 5 there, but it also equals 5 over here and over there and over there and over there and everywhere on this line. So y equals 5 is a straight across horizontal line at 5. Okay? If it were x equals, it would be a straight up and down vertical line this way. Okay? Okay, now for these we have to do some work, alright, because they're not in slope-intercept form. So I have 2x minus y equals 1. Got to get y by itself. So first thing I'm going to do is move the x. So I'm going to subtract 2x from both sides. I get -y equals -2x plus 1, and then divide. So in this case I have to divide by -1, and I have to divide everything by -1. So y equals 2x minus 1. Okay, so y-intercept of -1, slope is 2, so that means I'm going to go up to right 1, up to right 1. There's my line. Okay. Same thing here with number 16. So the first thing I have to do is move the x. So I'm going to subtract 7x from both sides. I'm going to write it over here so we have plenty of room. So 3y equals -7x plus 9. Then divide everything by 3. Okay, so y equals -7/3 is already simplified, and then 9 divided by 3 is 3. So I have a y-intercept at 3. -7 means I'm going to go down 7, so 1, 2, 3, 4, 5, 6, 7, and then right 3. 1, 2, 3. There's my next point. That's what my line looks like. 2 more. So again, got to get y by itself, so move the x and then divide. So I'm going to subtract x from both sides. I have -y equals -x minus 4. Divide everything by -1. Y equals x plus 4. Okay, so my y-intercept is 4. There's no number in front of the x, so I know that it's a 1. It's just not written there. So if my slope is 1, it's going to be 1 over 1, so it's up 1, right 1. Remember, we also said we can reverse the slope, so I can make this -1 over -1 and go down 1, left 1. Okay, it doesn't really matter. Either way, we get the same line. Put my arrows on both ends. One last equation. Move the x and divide. That's all you got to do every time to solve for y. So move the x means subtract 7x from both sides. So I'm going to come down here and write it so we have plenty of room. Negative 5y equals negative 7x minus 10. Last step is divide. So divide everything by negative 5. All right, move the x, divide. Move the x, divide. Negative 7 divided by negative 5 is positive 7/5. Negative 10 divided by negative 5 is positive 2. So I put my line at 2. All right, and I have 7 over 5. Now, if I went up 7, I'd be way off that graph. So I'm going to reverse it. I'm going to do negative 7 over negative 5. So I'm going to go down 7, 1, 2, 3, 4, 5, 6, 7, and then left 5, 1, 2, 3, 4, 5. And there we go. All right. If there's still something you don't understand, send me a message on Remind or Twitter, and hopefully I can help you out before the test on Thursday.